Go, 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 go!
Hi, we are Group 56, and I'm Kyle.
I'm Sophie.
I'm Yue.
I'm Mitch.
I'm Simon.
And our topic is the movement of icebergs and the ocean currents that affect those icebergs. We hypothesized that density differences in the ocean water causes ocean currents and in turn causes icebergs to move. Thermohaline circulation occurs when seawater on the surface evaporates, when air passes across picking up water vapor. Water evaporates, but salt does not. Since there is the same amount of salt and less water, the seawater's density increases. The increase in density causes the upper layer of water to sink, causing the lower, not less dense, water to rise and take its place. This is how deep water currents are created. There are three layers in the ocean. The epipelagic zone, from the surface to about 200 meters deep, the mesopelagic zone, from 200 to 1,000 meters deep, and the bathypelagic zone, from 1,000 to the ocean floor. Wind-driven circulation causes surface currents and are generated primarily based on wind. The wind stress acting on the surface of the water induces its movement. Since wind varies from place to place, it can cause upwelling or sinking of surface water.
One way to describe the flow of mass amounts of fluid throughout the oceans is through the conservation of momentum and conservation of energy. When the two are put together, it results in the Navier-Stokes theorem shown below. The fluid is assumed to be incompressible, and it is assumed to be a non-Newtonian fluid. It is an intrinsic way to represent a small volume or particle of fluid compared to a larger quantity. The rate of change and advection out of the region is also taken into account. It generalizes a flow of heat which compares to a natural convection. Natural convection occurs in our oceans by way of current. In the lowest layers of the ocean, it may take a few years to circulate. Other forces, such as Coriolis effects, also affect the currents.
To dive into the complicated world of the movement of ice sheet, glaciers, and icebergs, it's important to understand the fundamentals of what's happening in and around the ice. Glaciers flow because of permanent deformation due to the stress caused by ice sliding. The process is like the warm water goes to the bottom of the ice shelf and melting the ice shelf to create the iceberg. Eventually, icebergs form when giant chunks break off from glaciers and end up traveling with the ocean currents. Many believe that the wind is the main cause of movement once this ice breaks away, but since 80 to 90% of the iceberg is underwater, the upper ocean currents is what really force them to move. The Glen Nile flow loss shows that the flow is relative to the shear strength and temperature. While the shear stress is the product of viscosity and area, so the iceberg has a large part underwater will be affected more. That's why a large iceberg may move in a direction different from that of the surrounding ice. Since ocean currents at depth may differ in speed and direction from surface current.
Not only do the ocean currents cause the movement of icebergs, but icebergs can in turn affect the ocean currents as well. According to scientific research, cold water is denser than warm water. Furthermore, salt water is denser than fresh water. The general pattern is that the water heated near the equator travels into higher latitude and colder water, where the water naturally becomes cooler. As this water cools, it becomes denser and eventually sinks, allowing warm surface water to flow over and continue the pattern. Scientists have since found that the melting of icebergs can change this. The melting water can affect the salinity of the surrounding water because the massive amount of fresh water would be mixing with the salt water, causing the density to drop. Ultimately, this process can slow down the surface water from gaining salinity. As the Earth warms, the Arctic sea ice has been melting at an incredible rate. The more icebergs, the more influx of fresh water in the salt water flowing at high altitudes. This creates these areas of the ocean current to become fresher, hence less dense, and this will ultimately have the potential to disrupt the pattern of the ocean currents.
The ocean currents keep Europe mildly warm. Changes in this pattern, as said before, can change the climate as we know it. One theory, which was heavily researched by the National Oceanic and Atmospheric Association, is called the Heinrich event. This event, although it happened around 13,000 years ago, describes when the ocean circulation was disrupted by the melting of a vast amount of icebergs, therefore decreasing the density of the water. This was at the same time when the temperatures in the North Atlantic region cooled around by 5 degrees Celsius. There was still a lot of research that has yet to be done to prove this, as it's just a theory, but it's a pretty interesting one.
In conclusion, our original hypothesis was correct regarding that density differences in ocean water causes ocean currents, thus causing the movement of icebergs. We have since found that not only does this phenomenon happen, but the melting of icebergs affect ocean currents as well, which can potentially cause the cooling of certain areas of the Earth.